So we are given the following problem here. 3 out of every 4 trucks on the road are followed by a car, while only 1 out of every 5 cars is followed by a truck. And we want to know what fraction of vehicles over a long period of time on the road are trucks. Now, this is a word problem, but we are going to depict it using a probability transition matrix. So we are going to let 0, this is going to be the 0th row and the 0th column, correspond to car. So in the 0th column, it's going to be the probability of being followed by a car. And the 0th row is going to be like at that current state, it is a car. And then we're going to let 1 correspond to truck. So we may write out our matrix here. It's going to be 2 by 2. Now it says only 1 out of every 5 cars is followed by a truck. So that means this is going to be 1 over 5. And then this one, 3 out of every 4 trucks is followed by a car. So we're going to put that here. Now, because this is a 2 by 2 matrix, we may use the complement rule. So 1 minus 1 over 5 equals 4 over 5. 1 minus 3 over 4 equals 1 over 4. So that is the appropriate matrix to depict this problem. One key assumption we had to make here is that only cars and trucks are on the road. I don't know what they consider vans or whatever, but we are assuming cars, trucks only. Otherwise, we cannot implement the complement rule. Now, to get the long run portions of each vehicle, we may use this formula. So this corresponds to cars. This will equal this value here. So we just go along down. It'll be 4 over 5 times, we'll call this pi 0. And then we'll add this plus 3 over 4 pi 1. And pi 1 will equal 1 over 5 pi 0 plus 1 over 4 1. And then we'll note, because we are assuming cars and trucks only, that 1 is going to equal this being the total proportion of vehicles, or the total amount of vehicles, no, proportion, of pi 0 plus pi 1. Now we have a system of equations with 2 unknown variables. We will first note that this equation here implies that pi 0 equals 1 minus pi 1, and then we can plug that value here, and we are going to get the proportions. So we will start right here. So we will start by plugging in 1 minus pi 1 into this value. So we know that pi 1 equals 1 over 5 times 1 minus pi 1 plus 1 over 4 times pi 1. As we can see, this equation is exclusively in terms of pi 1, so it now should be easily solvable with a little bit of algebra. So we can expand this. So we have 1 over 5 minus 1 over 5 times pi 1 plus 1 over 4 times pi 1. We are going to swap the position of the 1 over 5 here and the pi 1 here, so all pi 1 terms are going to be isolated on the right side, and all constants are going to be on the left side. So that means that we have, this implies that negative 1 over 5, because we're switching sides here, equals negative 1 over 5 pi 1 minus negative 1, or negative pi 1 because we're switching sides here, plus 1 over 4 pi 1. Now we can note that 20 is the least common multiple of 4 and 5, so we may write this as, we're going to multiply the numerator and denominator here by 4 and here by 5. So we will have negative 4 over 20 pi 1 minus, we'll also have to multiply this by 20, so we'll have minus 20 over 20 pi 1, and then we'll have plus 5 over 20 pi 1. And then we may simplify this, so this means that negative 1 over 5 equals, and what do we have here? We have negative 4 minus 20 equals negative 24, and then we'll have plus 5, so we will have negative 19 over 20 times pi 1, and then we may multiply both sides by 20 over 19, or negative 20 over 19. That implies that pi 1 equals 4 over 19. So that's the proportion. Followed by truck. And we can check here. Or that is the proportion that is a truck, excuse me. We are done. However, we can note that 1 minus 4 over 19 equals 15 over 19 equals car proportion. And that is all we needed to prove. So we are done.